We will see in this tutorial using a 2D drawing to produce a 3D volume model. We will thus be able to anticipate the hydrodynamic performance of this surfboard. This example drawing in 2D shows us the outline, the rocker, and the sections of the new board. We will be using Shaper Wave Dynamics to create and test this new board. We start by loading a basic scalable board, for example. First thing to do when loading a model is to make a copy, because the default models with the HydroScan are protected and cannot be modified. So we are going to create a copy of this board model. So we load the copy. Here is that copy. We see that it has no HydroScan. So the shape of this board is modifiable and we can do what we want with it. We will start by applying the image of the 2D drawing outline as a background image. So I'll start by applying my outline image on the bottom of the board. So I'm going to Board Aspects, Board Image, and in the bottom image, I will simply look for my 2D outline drawing. And so there we come to the interface for sizing images of outline models. So this interface, we have already seen it in previous tutorials. So at the top, we can move the drawing and center it. At the bottom, we have zooms, and here tools to enlarge, move, adjust the image. So I'm not going to come back to this because we've already seen it in a tutorial, so I'm adjusting fairly quickly. I zoom, I move the back a little to make it coincide. I put myself a little bit in the middle, a little too tall. I reduce the image a little here. I do save and close. I will call it image bottom. Crypto. And so here is my outline model image, which has been mapped onto the background of my board. So now I go back to my shape area and I can draw my outline from this image. So here, as we saw already in the tutorial images outlines, we will simply put the points, so that they correspond to the drawing of the outline. So for the nose, I already take some points by hand. Then we use the line tool. So here is our outline drawing, which has been flattened. We will adjust if necessary afterwards. We will now see how to apply the rocker. So here we have our rocker plan. The rocker tool is here. In our rocker tool, we have a transparency setting here. So the whole rocker tracing interface can become more or less transparent, following a list of 3 settings. So here, at 50, you can't see much. I prefer to stay at 80. And in fact, we're going to juxtapose this interface with our rocker image. So, we open our drawing software, we put our image in plan here and we are going to match the rocker. on our image. So we're going to resize here the Shaperwave Dynamics rocker drawing interface, and we're going to come through transparency, look at the rocker. We will therefore deactivate the corner rocker, which is in green, to keep only the central rocker. And we're going to put our rocker on our model, to get the same rocker. We are careful to size the interface to the same width as the drawing. We are going to see a little finesse here at the rocker level, in the way of measuring the rocker compared to a reference. In this plan, the board is placed on the center of the board. While in theory a rocker is measured relative to the wide point, so a little further forward here, to respect the wide point as a reference, it would have been necessary to tangent the bottom of the board at wide point. Here we rather tangent on the back. In reference to the wide point, we are supposed to pose on two equidistant points in front and behind the wide point and balance on the horizontal. If it hasn't been the case, we have a tangent in the middle. Ultimately, we do well as we want. The important thing is to know what we used as a reference. But rocker measurements can vary from one method to another. If someone tells you, for example, that they put 80 mm of rocker in the front, if you took a bottom tendency of the board, more or less forward, you have more or less tilted the board, and the measure will no longer have any value. In terms of comparison, so, in theory, we align ourselves on wide point, we take support at equidistance on each side of the wide point, and we determine the horizontal width this level. The support distances are given according to the specialized literature, at 50 centimeters on each side. For reasons of shape stability during scale variations, it is preferable to standardize the distances along the length of the board and take 0.25 times the length of the board on each side of the wide point to obtain measurements adaptable to scale variations. That was a small detail on how to measure the rocker. Everyone does as they prefer and according to their habits. So here I aligned my rocker line with the model in 2D. And saw that in fact the 2D model was aligned not on wide point, but on another position. The software will automatically produce the attitude of the rocker and reposition it. We will see that the rocker will turn and reposition itself on the wide point. The line no longer coincides with the drawing, but it is the same rocker. It's just that it has been adjusted to the right fulcrums. If I take my design behind and rotate it so it's balanced on the wide point and put the interface back on it. I'll get back to my rocker position, so that's just a matter of orientation of the rocker line. It's a technical detail to explain exactly what's going on. So here, my rocker is recovered. I return to my interface. So here I have my rocker line. I will now put the corner rocker line, i.e. the bottom line. I also wanted to match the central rocker. This generates a flat bottom, without concave or belly. It will make things easier for the future. There. I end up with a flat board. Corresponding to my 2D drawing. You see here, the dotted rocker line which defines how the rocker is aligned with respect to the wide point. So for the record, we have the wide point positioned here. We draw two support points equidistant, 0.25 times the length of the board, and we put this area there. In balance above horizontal, and that gives us the rocker alignment. From this moment, we will be able to make comparable measurements from one board to another. So we come back here and we're going to do our sections. For our sections we're going to do a bit like we did with the rocker. We're going to do it transparently, and for that, we're just going to prepare our drawing a little in advance. So our drawing here, we will recover these sections there by transparency, with the section tool. So to recover the sections, we will turn the board over. We will be able to come and collect the sections like that. We are going to modify the aspect to see, by transparency, the position of the sections. We go to the Board Aspect tab, select Wireframe and show the sections. We'll take the closest section, here it would be this one. So the two sections that frame the wide point are section 5 and section 6. We are going to apply the wide point section on these two sections. We don't worry about the width in terms of section because the width is given by the outline. The section will automatically resize in the outline. So we're just going to take its shape and then it's going to resize. So I select the section that I will apply. I go to the section tool, double-click on the small diagram, to open the section creation interface. And so here we see section 5. If I click here we go to section 6. What interests us is to apply the section, to the wide point on the two bordering sections. So the sections framing the wide point are sections 5 and 6. I take section 5 and post my drawing here. Behind, I put my transparency at 80 on this interface. And I'm going to zoom in a bit, the background drawing. I match the center. In the center. So the green line here in my diagram, is the bottom line, and in fact this bottom line, it will determine, if our profile is more or less concave or V-shaped. Afterwards, in the section drawing, we can make trough, but the overall alignment of my bottom line is determined by the little green line, which can be manipulated, with the rocker interface. We did say that there were two rockers. I go to the rocker interface. So we have two rocker lines. We have rocker at rail level. If we modify the rocker at the level of the rail, for example, here we are on section 5. If I come down more or less, the green line, if I take this point and come up the green line, what will happen? I apply to the project. I see that it's my whole section that goes up here. So in fact, if we want to copy a section, we will also set the bottom line. So in my drawing, you have to look at the bottom line. Is descending or ascending? So here, we have a bottom line that goes down. So there is a bottom slope. The corner rocker, rails rocker, point is a bit lower than the rocker. So we sit here, we are going to lower the green line, so that it corresponds well to the rocker of rails. I will slightly lower this point there which represents the rocker of rails. It is necessary to apply. We are going to raise everything to show a little better. Here I have my line here with my section on my drawing, and my goal is to bring the bottom green line down, to match the bottom line of the section there. So I apply rocker to the project, and see the bottom line of the section tilt slightly. Is that enough? No, it must be lower. I can increase the transparency to see better, so that's the line behind. At this point, it must correspond, therefore in the center, here it is done. And the point here there, it has to match this green line here which is behind the section. It must match the model line. That's why I'm going down again. So there, it's not bad, we're starting to tangent well, so there you go, I'm going back with a little less transparency here, so I have my center point of this section, at the wide point, and now all that remains is to apply the thickness, to my model. So here is how we copy a section from the 2D model. With the interface, this allows for good precision and good use the 2D plan, to the optimum. So, I set my rails here. Here, I could then modify and adjust each part as I want. Here I have my section which is corresponding to my model. Here, I apply it to the project. I will reduce this one to see my project. So here what I did is apply my template to section number 5, section number 5 being here, so I'm not going to redo this work every time. So here, I know I have to apply the section around the wide point. So I select this section in the interface, I copy. So copy complete cut. I copy, we can do Ctrl C, I select section number 6. I'm going to paste, or Ctrl V, paste the section. So we don't preserve the current board thickness, because we really want to apply this section. So by clicking on No So here, these two sections have been applied to the board. Now I will duplicate the tail section and the nose section by copy. Exactly as I did the first time. So here it is, this being done, we have our project. So we'll see now. With the nose here how we will copy and apply to the previous section. Same for the tail, we put it here and we apply it to the next section. Okay, we will remove the bevels from the rear. We will say that there is no chamfer behind. And then there you go. So here, distributed are known sections from the 2D drawing. Now we are going to do the middle sections. We are going to use a trick here. We are going to mix sections. We can copy the sections, so are sections of our 2D plan. We can copy paste it here. And in fact, we can get our back section here copy. Ctrl C, and we can make it come to merge. So that will give us a mix of these two sections. So we have an intermediate section. And now this section here is a mix of the wide point section and the tail section. We would like this section to be closer to the wide point than to the tail, in terms of shape. So we're going to copy the wide point section again, and merge it again, to give it even more the character of the wide point section. So we did here a hybrid section, which was therefore the first time, the average of the wide point tail section, and once again averaged over the wide point section, to give it a character more like the wide point. This hybrid section I'm going to copy and paste it here. And I'm going to give it a bit more character of the tail section. So I do copy the tail section, I come back here and I'm going to merge with the tail. Thus, I created a kind of hybridization of my different sections. Here I have two more sections that have not been worked. So here I have the nose section. I will copy paste it here, paste. I copy my wide point section here, copy, and I just merge it once here. So here, now we have a section, which is an average of wide section and the nose section. I would like it to look more like the nose section, than the wide point section, because it is closer to the nose. So I copy the nose section again, and I just merge it again. And so we created a section that was twice as similar to the nose section as it was to the wide point section. So I don't know if it's all very clear, but in any case, it's very effective. Just copy paste. So here I copy the wide point section. I want it to be intermediate with this one, so I copy this one and I just merge the sections. That's how I created gradients of sections in continuities from front to back, with a system of merging the sections together. And all the missing sections, which I didn't have in my plan, I extrapolated them as well. So that's the first thing, and at the end we have the shape tool, which allows us to adjust, extrapolate, and ensure that all the sections are harmoniously distributed with respect to each other thanks to smoothing. This is the clean shape function. And there, all the sections will be harmonized so that there is no big difference between each point. And so I'm basically taking back my board. Well, I'm going to put it back in volume aspect. And so here I took my board back. Just one thing to finish. On the rear section. So the shape, at the level of the tail section, I will select here in Shape, Guide section. The shape of the tail, is it we make a chamfer, or not? We are going to make a medium chamfer. Here it is. Like this. Same thing for the front. It's a medium chamfer already at the front. We can of course adjust the shape. So indeed, a little weird here. We're going to adjust here. And here is our board has been adjusted. Okay, so for this board there, what I'm going to look at now is its volume. So if you noticed, I have never worried about dimensions in terms of millimeters or feet. I only work on shapes. So here it is, this board, which is given for 1727 millimeters. So I will adjust the size, here, 1727. So now we apply the size. Here we are, and we will check if our set is consistent with the volume that is announced. Normally it is volume of 30.9 liters. Here I am at 31.9. The only thing I have to do is adjust the volume globally. There. Here I go back to 30.9. So I have a board that has the outline, volume, and sections matching my model. I will of course be able to adjust the different areas, such as the sections, to see if I am very clean in terms of the shape of my rails, etc. We will be able to work well on all the shapes of rails and come back to something cleaner if needed and desired. So here we are going to stay like this. So I made a copy of my 2D plan in 3D. I will now be able to either do STL export, or, which interests me much more, create a shaper report, to see what the hydrodynamic performance of this board is. This will be the subject of the dynamics tutorial. Shaper Wave Dynamics software.